Okay, let's go ahead and get started. I'd like to thank everyone for joining us today to today's webinar, GitOps Continuous Delivery with Argo and Codefresh. I'm Julius Rosenthal. I'll be moderating today's webinar. I'd like to thank our presenter today, Brandon Phillips, Solution Architect at Codefresh. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF, and as such, you are subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. We'll have the slides and recordings up later today on the CNCF webinar page. With that, I'll hand it over to Brandon to kick off today's presentation.
All right, thank you so much, Julius. I appreciate the introduction. First of all, I just want to say thank you from everyone at Codefresh for joining the webinar. We think it's an extremely interesting topic, so I hope you guys enjoy it. As Julius mentioned, this is a webinar on GitOps Continuous Delivery with Argo and Codefresh. So, next time we'll make sure we think of an even longer title. And just for a little bit of an introduction, so I am Brandon Phillips, Solutions Architect, as already introduced. So I am working with Codefresh, primarily working with customers on DevOps solutions and CI/CD. I have a history in software development and software architecture for the last 10 years or so, and just really heavily specialized in Kubernetes. And just for an agenda and overview here, we're going to have a light intro into Codefresh because you are going to be seeing it quite a bit during the demo periods. And then we'll cover just GitOps principles, why we think it's important, and we'll dive into Argo CD, do a demo around GitOps, and then we'll dive into Argo Rollouts and we'll demo a Canary Deployment. So we are doing live demonstrations, so hopefully the demo gods are with us today. Oh, and one other thing to call out here. So we do have the links to the GitHub repos here. So, once the slides are shared, if you want to take a look at the applications in more detail, you can. It's a very simplistic application for a web service, and then just the necessary code to create an application manifest and an Argo rollout. And I'll show you little bits and pieces of that as well. And so Codefresh is an enterprise CI/CD solution. So we are a Kubernetes native solution. We provide container-based pipeline processes, and we give you a way to cleanly tie into your Kubernetes ecosystem using things like Helm and really advanced pipeline processes. So one of the reasons that we're having this talk today is we have decided to heavily invest in Argo and integrate it with our tooling. We see a great opportunity there to make our CD solutions even more robust by integrating with Argo. And so you will be seeing our products. So that's why I wanted to give this little intro here. And this is where the pipelines are built out in. So you will see a little bit of that. And if you have questions about it, feel free to ask at the end. So GitOps as a goal really is something I want to talk about because it's important to understand, why we think GitOps is fundamental to good CI/CD practices. So it's making sure that your process to deliver your code is repeatable, that you're applying your changes in whatever environment you want to push this out to in the same way every time. In some cases, you can even push out your entire stack. Like Codefresh, for example, we use pipeline processes and Helm charts to be able to deploy out our entire stack at the same time in a declarative manner. So this is extremely important to have that repeatable process because you have less moving pieces that way. It should be predictable. And this goes right back to the repeatable portion as well. So you should know when you put in that pull request exactly what the end state of the application is going to look like. So having that declarative configuration with a known end state is extremely important. Knowing that if I make this change, my replicas have to be at 4 instead of the 2 that it's at now. Otherwise, this is a failed deployment process. So using declarative configuration, that end state before it happens. Therefore, it's going to be a predictable deployment. And if it did not match that end state, then it was a failed process, and that gives you the opportunity to roll it back. And the same goes for auditability as well. So making sure that every change that you push into your production or your staging or even your development environments are historically traceable back through the code commit, but also all the way up through all of the deployment process. And this becomes crucial, especially in organizations who are trying to debug or understand an issue that happened in production, to know that, 2 weeks ago at 1 p.m., I know exactly what version of my code was running in production, and I can look exactly at the declarative configuration that specifies not only my application code, but also the infrastructure code around it. So you should have, a declarative configuration for both your infrastructure and applications so that you can recreate environments if necessary in a lower environment. So that auditability is really key to quickly triaging and dealing with issues as they come up. And then making sure it's accessible. I really like that you can control this with pull requests so that, not only is it very accessible for basically anyone who can use Git tooling, or in some cases, they can, if they're not comfortable with it, say you're using GitHub, you can just go onto GitHub, modify the file, and it'll even prompt you, instead of delivering this to master, do you want to create a feature branch and create a pull request for that? Having those easily accessible options to expose it not only to developers who are comfortable and happy in tooling like this, but maybe some of the, groups like security or server teams that this isn't their bread and butter, but they can get in there and easily make these changes. So having that is a huge win. The other thing would be putting it in a pull request means that you can refine and control the process. So what you can do is you can actually create separate pull request approver groups based on areas of responsibility. So if you have application code that's part of your pipeline process to deliver, and you have infrastructure code that's part of your pipeline process to deliver, you might have different approvers for each of those areas based on who owns the cloud infrastructure versus who owns the development applications. So we feel like, having that pull request process as part of this is just crucial. And then I want to talk about actually practicing GitOps, because talking about these principles are great. There's obvious benefits to the things that we talked about, but practicing it is extremely important, and it leads to some really good benefits. So the first being, Git should really be your system of record. And that means, your desired state of configuration for your applications, your infrastructure, whatever is a moving part of the puzzle in your deployment process and your continuous integration process. So, having that one system of record, that one store to go back to and look at, makes it very easy to make it traceable, to make it repeatable, all the things that we talked about. And we already kind of discussed this, but it's making sure that everything is driven by pull requests. And I wanted to highlight this here again, because it's important to understand that we know that there are occasionally, some heroics that happen where you might go in and backdoor your Kubernetes cluster to make a change to kind of make things happen. I understand that on occasion that still ends up being necessary, but the goal at the end of the day is to push that through a configuration change. So there's that level of traceability in there. Because realistically, the next time you go to deploy that application, if you don't have a historical record of those changes, you're likely to end up in the exact same situation. And then the cluster state always needs to match the Git state. And more importantly, the tooling that you're working with should be able to understand and monitor for configuration drift. So if you have tooling that is aware of this, then you don't need to do the legwork. You don't need to do the manual testing and checking to make sure that, yes, the version of the application that I expect to be deployed out there is actually deployed out there. So having tooling like Argo CD that is aware of the state of the application is extremely important. And deployments and rollbacks should be painless. I know this sounds like something that's obvious to say, but we work with a lot of customers who, they're coming to us because they want to get away from deployment processes that are an all-day affair, all hands on deck. Everyone's in the, in like a war room working on the deployments, and your rollback should be similarly seamless as well. So if everything is driven by a declarative configuration, then it's just as easy to roll back as it is to deploy an application. Now, of course, that might mean that you're out of sync with your current configuration until configuration changes are pushed, but it's still crucial to be able to do that quickly in an environment so that you don't have any problems, long-term that you can't resolve. And then developers can and should focus on feature development. So this is interesting to me because I'm not saying that developers should not be managing their own pipelines. I do think that shift left has some really good merits, and developers actually should take some ownership of the pipeline processes to deliver their code. Now, what I do think is that once those are established and in place and they're running well, then they should be able to focus on their feature development. You should have your CI/CD process in a place where your developers don't have to be focused on triaging, minor issues that might happen in a development environment, or, trying to figure out what happened when they deployed to this specific staging environment. If everything to configure and require your application to run in a Kubernetes cluster is part of that pipeline process, it's going to really alleviate the need for developers to get in there, dig in, go hands-on on, exactly why my application isn't deploying or behaving the way that I would expect it to. And then Argo CD, we really think that Argo CD is a phenomenal tool for continuous delivery. And it goes back to a lot of the principles that we were talking about. So it is built around being a declarative GitOps continuous delivery tool. And it's extremely feature rich. So all the things that I just highlighted here. So they support rich templating. So whether you're pulling in from an application manifest, you want to use Helm charts or customize, all you need to do is point it to your repository, specify the templates that you want to pull in. And then from there, those actually drive the configuration and synchronization process for your application. And we already kind of discussed this, but it's that configuration drift. So I'll show you in the UI that Argo CD is acutely aware of the state of its application in the cluster versus the state of the intended application in your Git repository. And it will actively tell you that. And not only does it allow you to manually sync or use the API or CLI to do that, but it also has an auto synchronization policy that you can set that says, hey, like it noticed a change in your Git repo, we're monitoring it, and we're going to go ahead and update that. And by default, Argo CD, if you set up autosync, it's pulling that Git repository every 3 minutes. With this demonstration, we're going to show a little bit different approach where Codefresh is going to utilize the rich webhooks to actually actively engage it. But yeah, it can also auto pull. It's also enterprise ready. So, all the items that I'm mentioning here, like SSO, multi-cluster, multi-tenancy, audit trails, the stuff that you would expect, but even the more nuanced things like how do I deal with high availability needs? It has automatically built out so it can specify that you can do high availability for the Redis backend and things like that. They have disaster recovery built in so that you can dump full configurations if you need to. And then it's also just, resilient as well. So it can lose the Redis backend fully and be brought back up and still be in a runnable state. So it's very enterprise ready from that needs. And then it's very extensible as well, which really lends itself to being enterprise ready. So they have a rich CLI that you can utilize, webhooks, which Codefresh is tapping into. They can do event-driven architecture to drive your deployments, polished web UIs. And although I don't list it here, in part of that extensibility would be what they call app of apps or app projects, which is actually a custom Kubernetes CRD, which actually allows you to specify groupings of applications so that you can have your dependency chain managed and understood by your continuous delivery tooling. And so this is going to be a brief introduction to what our demo is actually going to cover here. So we have our nice little developer guy down here. And our developer is going to commit some code, so into the main source code here. From there, that source code is going to trigger an event on our CI/CD platform. In this instance, we're using Codefresh. Obviously, it could be other tooling here, but in Codefresh, we have a trigger interaction to say, looking at this repository for changes, and it's going to trigger an event in our CI/CD platform. From there, Codefresh is actually going to handle updating the application manifest. So we're talking about the Kubernetes application manifest, and we're going to change the version of the application. When we change that version of the application from Codefresh, it's going to trigger a continuous delivery pipeline. And that continuous delivery pipeline is where we have our built-in integration with Argo. It's going to say, okay, I got the request. I know there was a code change. It's going to go out and it's going to call Argo CD to sync. Now, this is where Argo CD's magic really comes in handy. So we have our webhook interaction. We're going into Argo CD. We say, okay, we know there's a code change. The application's now out of sync. So you don't have to worry about the auto sync or the time policy. And once we make this interaction with Argo CD, it's going to get the latest from the repository and it's going to update our application to the newest version. So we went from our older version to our newer version here based on configuration sync. And now, once that application is out here, let's say that for whatever reason, the trigger gets turned off in your CI/CD platform, or something else happens where someone goes in and they actually make a change to the file without it being picked up by the platform. We would see that we were now out of sync in Argo. So Argo, again, monitoring it, would know that we're out of sync for the configuration. And if you had the auto sync policy turned on, it would then go ahead and go through the deployment. And so now we're going to drop over to the actual demo, and this is kind of the live demo part. So hopefully this is going to go well. I do want to talk through a little bit of what the actual pipeline process looks like. So if we take a look at, so I'll drop in here and we'll just go to our main Codefresh area here. Okay. Running a little minor snag here. So if we'll start by taking a look at Argo CD here. So if we drop in Argo CD's UI, the first thing you'll notice is you have applications here. So the applications are what you're going to add in that are actually syncing with your code repository. And then from there, that will actually determine what's in sync with your application. Now I have the Canary one already out here, but I do not have our application for our GitOps demo here. So what I'm going to do is I'm going to go ahead and create that. So give me just a moment here. And so we'll go in, we'll do a new app. Inside of our application name, I'm going to name this GitOps app, very generic and creative, as you can tell. Our project is just default, that's fine. Repository URL, in this case, we're actually using an open source repository. So in this instance, you don't have to set up any special configuration. Now, if you need to, you can actually have SSH enabled repositories as well. So it supports connecting into private repositories. So this would be the link to our main repository. For our path, I'm just specifying dot. So it's just saying, look in that root folder there. And then from there, for cluster, I'm going to use in cluster. Now, this is an important distinction. In this case, for the sake of this demonstration, I am just having the deployment happen in the same cluster that Argo lives in. You do not have to set it up that way. So you can set it up so that Argo has its own dedicated cluster. And then if you add in an external cluster, they get stored as secrets inside of the Argo CD cluster. And then in this case, yeah, I'll put it into a namespace of its own. So this is going to create that application. And I will show you what that application looks like. So if we look at GitHub here, so the directory that I actually sent it to is actually the directory that's containing the application manifest and the service definition. So it's not actually the source code. This is the manifest that's driving the deployment of the source code. And if we take a look at this, this is just a standard Kubernetes manifest. And if we drop into this guy, we'll notice that we have our application in here now, but we are out of sync and we don't have a deployment out there. And if I take a look, so take a look at our clusters here, we'll see that, okay, I do have my namespace in there. And I don't have any deployments right now. So there's nothing actually running out there. So what I can do is I can hit synchronize here, and this is from within Argo CD. You know, later I'll show it with Codefresh, but if I hit synchronize here, this is going to bring us up to the current state of our application. And you'll see that it starts to spin it up. And of course, this was previously a deployment, so it comes in super fast, and it's going to start to synchronize. It says, okay, based on the manifest that you gave me, I know that this is the image that we need to be using. It's going to start to sync that process up. And then eventually when it gets a determination from a health check back from both of these guys, the running applications, this is going to be in a happy state. And so now if I go and I take a look again at our deployments that are out there, you'll see that I have 2 deployments for the GitOps app, and I have 2 pods. And both of the pods are running and they're healthy. Now the application is extremely simple, so there's not a lot of complexity here. But if we drop in, we can take a look at what's actually running. And it's, I think it's a pretty interesting color right now. But basically, it's just a web service that's exposing out a base web page. That's really all that it is. And then we will take a look at the pipelines a little bit, because I want to cover a couple things in here. So if we drop in, okay. Just give me one moment. So it seems that Codefresh is responding a little slowly at the moment. Or is it my internet connection? Are you able to hear me okay, Julius?
Yeah, I can hear you.
Okay. All right. Well, let me go ahead and we'll push through with our code commit and see if we fire off a build. So inside of here, this is just our application for exposing the web service. So very simple stuff. I'm just going to change it to a different color. Not a big deal here. And we'll go ahead and add a message to this. So, and then we'll just commit it. Oh, yeah. Let me go ahead and add that guy in there. And then let me go ahead and push these changes. And so that's going to make a commit into our primary repository here. And that's what's actually going to trigger the event. And if we drop back over here, let's drop into our application. Oh, I got booted out. All right, well, I guess I will log back in. That might be the snag that we were running into here. It seems like our page did come up here now. All right. Well, I guess while that's kind of taking a break a little bit, we'll go ahead and we'll start talking through some of the other aspects of Argo CD and kind of just move on through the presentation portion here. So hopefully we'll be able to get back to that demo. But if not, I do want to talk about some of the features of Argo Rollout, which what that's really doing is it's applying advanced deployment strategies for your Kubernetes environment. So it gives you a custom Kubernetes CRD called Rollout that allows you to specify whether you want to do a blue-green or canary deployment, and then add a whole bunch of additional criteria on there. And there's some key things that I want to talk about here. So there's service mesh support. So I know that there's a lot of companies right now that are looking forward to integrating with service meshes or adding in support for service mesh in the future. And as you kind of roll to that, you know, making sure that the tooling that you're picking is compatible with that. So Argo is compatible with service meshes. So it supports Istio, Linkerd through SMI. It also supports NGINX. A lot of the key players that you would also anticipate there as well. And then now this is very important to me personally because we use a lot of auto scaling, but it supports anti-affinity and horizontal pod scaling. So what that really means is typically, you know, if you're deploying an application, historically it would be I'm deploying an application, it's going to go to whatever pod has resources for it. And in that instance, you know, you can end up in a situation where the resources actually get deployed, but then you've auto scaled up to fill the needs of additional applications. That can cause a problem with you because you might end up with a remnant of, say, one pod left on a node when you try to scale things back down, when really you wanted that node to be able to go away. So Argo actually has the capability to specify anti-affinity so that when I have a previous application version, even if there were resources available on, say, this pod and this pod on these nodes, those should say node instead of pods, but on these nodes, then it would deploy to new nodes entirely so that you could auto scale down these nodes. So that's a huge win for customers that want to be able to use that anti-affinity and auto scaling inside of Kubernetes. Another aspect to talk about is analysis control. So Argo Rollout has this concept of analysis where you can tie into specific metrics using Prometheus to say, you know, as part of my Canary process or my blue-green process, I want you to go out to your Prometheus instance and I want you to analyze these specific metrics. And you can even specify pause breaks in that as well. So for example, if we take a look at our actual application deployment here, we're doing a canary, that's what we're going to demonstrate here, but we have our steps in here with a set wait and a pause. And so what they allow you to do with the rollout CRD is actually to specify your analysis as part of a step in a pause period, or it can even be analysis higher up to say, let's say, for example, that I'm doing a blue-green deployment and I have a preview application out there. Your analysis can actually happen against the preview version of the application as well. So it gives you that flexibility to set the analysis up. And the other thing that I would recommend, particularly with Codefresh, what we like to see is, you can bake it into your deployments here. You can also bake it directly into the CI/CD process as well. So if you wanted to make it part of the actual deployment process, you can do that. And so that's extremely important to doing rollouts like Canary and Blue-Green, because you want to make sure that it's in a healthy state when you actually try to go through and roll out the rest of the application. And so talking through what a Canary deployment would actually look like. So again, we have our nice little developer down here. Our developer is going to commit code. And just to kind of talk about where the current state of the application is, right now we have 4 instances of our application version out there. When a developer actually commits the code, it's going to trigger that CI, just like it did for the GitOps-based pipeline. From there, your platform is going to do whatever it needs to do. And this is, in our instance, the pipeline that we had set up for this is very simplistic. So it's really just build an application, bundle it up, commit back to the repository. You're going to have a lot more complicated stuff in there. You're likely going to have integration testing, unit testing, security and vulnerability scanning, all that stuff that's going to happen in your CI. And if it actually passes all of those, then it would say, okay, we know that it's a healthy build. Therefore, we're going to update our rollout manifest, which is going to trigger that Canary CD pipeline. From here, your CI/CD platform is then going to make a call out to Argo. And this is a key thing to mention. So it's going to call out to Argo to do that rollout process, but also it's going to hit that pause event. And this is important because this is where you're specifying your actual threshold on how much you actually want to deploy the application. So if you have 4 instances, in our case, we want to do a 25% deployment. So we're going to deploy 1 new version of the application, which is going to happen here. And we're going to update our state to say, okay, we're at a 25% Canary status. That was what we set for our pause event. So we have Argo here now grabbing the latest manifest. And then from there, it's actually updating the state of the application. Now, if we take a look at our following steps here, what we're going to do once we're at that Canary point is then it's up to your platform to actually determine if that Canary is in a healthy state. So you can have, Argo doing some analysis via metrics through Prometheus. You can have your CI/CD platform during this pause state actually looking to tooling like, let's say, Datadog, New Relic, Dynatrace, or you might use Jaeger, Zipkin, or an Elk stack. You can kind of write your own custom process to go out and say, okay, is that Canary actually in a healthy state? If it is, then you can call to Argo to actually complete that rollout. And when you do that, you're saying, okay, I'm calling back to Argo. Here's the, here's the build that I'm looking to complete. And then from there, it's going to do a configuration sync as it actually stores your Git repository in its own local repo, and it's going to update that state. Now in ours, we only have 1 pause step in there. So at this point, what it would do is has a current state. It's going to do a config state. It's going to bring our entire application up to that new version. So we're going to go from 1 of the new versions up to 4. And so this is where you're now fully deployed on the new application version. And at this point, you've vetted it, that the application's in a good place. And now you're fully transitioned over to that new application. Now, that's not to say if you didn't encounter errors that you could roll back, because you absolutely could. And so this is where, we would be dropping into our demo time. And so I do want to show you in Argo what that would actually look like. So we have our applications here. We have our rollout app. And our rollout app, you'll notice that, first of all, we have a bunch of historical versions here. So we have our historical reference through our deployment chain. And with any one of these, we can actually specify to kick off a rollback process. So that's a feasible option as well. But what I want to show here is, because we have the historical reference to the previous versions, you'll notice that we have this current revision, which is our most recent and is also in sync with our repository. And in the repository, we have our 4 replicas here specified, and all of them are running off of that. And if we take a look at this, we'll notice that we have 1 image deployed. That is the primary image that we're actually working with here. Now, what you can do from within Argo is you can actually kick off a rollback process directly from within here, and we'll see the Canary process. Because one really cool thing here is, if you have a rollout specified as the deployment mechanism for this, just like we do in this guy where we're saying, we're using Canary, then when you actually do a rollback here, and so we'll go ahead and we'll kick it off. Now, again, this would typically happen from your CI/CD platform. But if we kick off a rollback here, you'll start to see that we are spinning up the previous version of the application. And in that instance, once this is up to a healthy state, what we should see is that we'll start to terminate one of these pods here as well. And so we'll have two different versions of the application actually running. And so that's giving us our Canary test bed. Now, again, if you were doing a blue-green version of this deployment, potentially what we'd end up with is 4 pods of the old, 4 pods of the new, and then allowing you to do your test analysis against that preview application. So now we see that we have 3 versions of the old version, or I should say the newest version, but really since we did a rollback, this is what we're anticipating to be the current version. And so we've done our Canary step. So now we're 25% rolled out. And this is where we're going to end up in a suspended state, because it says, okay, I was told by the declarative configuration that this is where I pause. And so I'm going to pause for any feedback, or any basically any future calls from an application to say whether or not I should continue with this rollout. And then from there, if we take a look at our actual rollout application, you notice we are out of sync, but that's because we did a rollback, but we are running off of 2 different versions of the application. And that's because we have 25% on that other version. And if I take a look, so let's go look at our actual rollout app here. All right, and yep. And so, it looks like Codefresh, yep, looks like Codefresh should be able to demo this as well. It starts coming up. Cool. So what we'll do is we'll actually do a code commit. So let me go ahead and refresh this guy to demonstrate that for you in general. So we are, again, we're out of a sync state here. So I'm going to go ahead and I'm just going to sync this back up. I'm going to let Argo just kind of handle that for right now. I'll drop back to our application where we created our GitOps app. And then we'll make a code commit here as well. And so I do want to talk a little bit about the pipeline process here. So if we drop in and we take a look at our GitOps CI, so there's a couple important things to point out to here. So the first would be, obviously we're doing our clone, our build, and this is where you could layer in much more advanced build steps, and we would highly recommend it. But this is where you would layer in your things like your integration testing. And then once we do that, we're actually updating the GitOps. So we're taking that file, we're appending it with information that we have from the trigger request. So we're adding that commit SHA on there, and then we're committing it back to the repository. And if we take a look at our trigger event here, we have a trigger set up on our code, so our actual code of the web application itself, saying if we get any push commits on this, let's go ahead and kick off this process. And currently it's in an on state. So now if I actually go back to our code, and we're going to do this again, so we'll change it back to, let's go chocolate, because why not? And let's save that guy. And then I'm going to push this. We'll drop back over to our build processes. And this is where we're going to see that our GitOps CI pipeline is kicked off. And so this is what's making those changes. And this is actually going to happen in parallel. So we're going to be cloning down our repository. We're going to be building out our image at the same time that we're cloning down our GitOps repo and potentially updating that manifest. But we're not actually going to commit the changes to the manifest unless the Docker image build is successful. And this is key to understand, because realistically, like I said, you're going to have a lot of testing events in here. So you don't actually want to kick off that CD process or the GitOps process unless the build itself is successful and all of the testing that you have baked in. So now everything here was successful. So we're going to see that we're actually going to push out a change to GitHub in this instance. So if we take a look back at here, so this was last updated 4 hours ago, we should see that this will be updated very soon. And this is actually happening through the CI CD platform. It's pulling it down. It's committed it now. And then from there, we're going to see that it was updated just now, and it's getting a new commit SHA, which actually came from there. And now if I go back to my builds, because we committed back to that repository, we're going to see that as part of our GitOps CD pipeline that now we're executing this. And again, this is where you might have your own, pre-synchronization checks or post-synchronization checks inside of here. But in this instance, we just have some dummy steps in there to kind of demonstrate that you can. But here, it's actually going to start that deployment process with Argo CD. So this is our current application. You'll see we just kicked over to syncing now, and you'll see that we're spinning up the new version of the application. We're spinning down the old version of the application, and now this process is in sync. So once this finishes up, we'll see that that fully goes away. We'll have a historical reference to that deployment, just like we did in the other instance that I demonstrated. And you'll have a good insight into exactly what changes happen. And if you wanted to, of course, you can click through the revision information and go directly to the code commit, and you'll see that it was just a commit SHA there that actually changed. But we have our new version of our application. And Canary is much the same process for us, except that we baked in ways to actually do additional testing. So if I drop back, I'll go to our pipeline for our Canary. And I actually currently have the trigger for this disabled. So I will step in. I'm going to go ahead and I'm going to turn on that trigger. So now if I make a code change, so let's go ahead and we're going to go, let's find something fun. I like deep sky blue. Let's go with that. So we'll change this to deep sky blue. If I could type. All right. And we'll go ahead and we'll commit that guy and we'll push this. And now when we actually push that, we will see that we're kicking off our Canary CI pipeline here. And this Canary CI pipeline is very similar to the GitOps one. The flow is the same. You would be doing the same testing, but instead of kicking off the commit to the GitOps repository, what we're actually going to be committing a change to is this rollout manifest. And we're going to change the version of the application. So it's very similar. So that flow from the, that beginning area is basically identical. And so we're building the Docker image again. We are pulling from cache for the entirety of this build. So it's typically pretty quick. And then we're actually committing back to that repository. So if we look at our rollout, once this commit happens, we should see that again, we just had a change. And then from there, we should kick off that CD pipeline. Yep. We see there is one change. There's Delta. We'll go ahead and commit this back. Now we've committed our change. So we see that we just made a change now. And if we look back at our build processes, we'll see that we kicked off a Canary CD pipeline. Now, this is where, you're really going to get more detailed in your analysis of whether or not this Canary is healthy. So if you're using Argo's analysis, you can take that approach. If you're using your CI/CD tooling to do it, typically you would roll out your Canary application here. You might even do some pre-environment checks to make sure that, everything that you're expecting to be in place is there. But once you actually specify this rollout, what it's doing is it's starting that rollout of the application. You'll see it's already started to synchronize by adding that Canary object. So the container's creating, and again, we went from one image being deployed to now 2 versions of the image. And then once we're at that 25% Canary status, like I showed earlier, the tooling itself, once it finishes this rollout process, and again, you have detailed logs on exactly what's happening inside of Argo when you're calling from our platform. So if you need to see more information, you can drop in here. It's going to tell you how that synchronization process is going. In this instance, once we're at that 25%, it's actually going to pause the deployment. So let's say that you had an environment for whatever reason you wanted to do, and you just saw that fourth version actually disappear, the fourth pod of that version actually disappear. This is actually going to get to a point to where, let's say you're going into like a local dev or sandbox environment, or maybe a QA environment where you have a QA group that's actually smoke testing it. So you should have all sorts of other analysis in there in place as well. But if you have a manual QA process, then what you can do is you can have like a pending approval step. In Codefresh, we call it pending approval, where you can layer in a gated deployment. So we've started the Canary and we now have 25% of our rollout completed, but we've now gated it to let you do any vetting that you need to do to make sure the application is healthy. So once we're, confident that everything's in a healthy state, we can say, okay, we're going to approve this. And now when we approve this, it's going to start to move towards the next process where it's going to say, okay, now we're going to promote the rollout. And this could be to another step. So you could have another pause in here. So it could say, We did 25%. Now we're going to go to 50 and we're going to pause again and we're going to do traffic analysis to make sure that everything's healthy. We're going to do error analysis and things like that to make sure that everything is in a state that is production ready in your case. In this instance, we're saying, okay, the pending approval is fine. We did our smoke test of the environment. We're starting the deployment process again. So if we take a look here, we'll see that our DIND is spinning back up, which is our execution process for our pipeline. And then we'll start to actually do the promotion process. And again, this is calling to our Argo CD steps. And then from our Argo CD steps, again, it's going to give us a link to say, okay, we'll drop you right into Argo so that you can visualize what's actually happening. And so you'll see that we're starting to actually deploy the newest version again. So we're upping the pods now. And as we get reports back that that's actually healthy and the health check has checked out, then it'll start to terminate pods that are running on the older version. And so it's really just automating that entire process. So the key thing here is that once these pipelines are set up, whatever your CI/CD platform is, your developers, all they need to worry about is committing code. And so if they have a feature that they're working on, all they need to do is actually commit that in, let the automation and the declarative configuration actually take care of it for you. And so there's really no uncertainty in the process. The only thing that I would highly recommend would be, and this for demonstration purposes, we don't have it in here, but typically what we like to see is you'll have your start of your rollout process. You're going to have your analysis and your health checking and things like that in here. And then you would have a conditional check to say, only do the rollout if all of that is good. Otherwise, we can automatically execute a rollback, again, using our built-in steps. And so to kind of talk about what those steps actually are, and it looks like, so once this updates, we'll be fully on the new version of the application as well. And we will see our 3 minutes ago for our deployment time. And so if we drop back into our pipeline, I want to talk about what our steps actually are. So we have a step marketplace, and in the step marketplace, you can run container-based steps, you can write code behind them. And we actually wrote steps to integrate with Argo CD. So we wrote a synchronization step and a rollout step. So this allows you to directly tie into your Argo instance and execute things that are webhook driven, directly tying your CI/CD platform into your Argo. And then we also are building heavily upon Argo. So we're also going to integrate it into our environments and things like that. So, Codefresh is really looking to make heavy investments in Argo and make it a big part of our platform. And so that actually concludes our demo portions and the majority of the presentation. So this really just opens it up to questions. So I hope that was interesting. I hope that it covered, at a high level things that you wanted to see with Argo. And I think at this point, let's just open it up to Q&A.
Awesome. Thanks, Brandon.
Yeah,
everybody, feel free to ask your questions down in the Q&A tab at the bottom of your screen. It looks like we've got 2 now. So Jindong asks, in a dev environment, there are going to be a lot of commits. How can we group these commits to trigger one build?
Yeah, so that's really interesting. So the first thing that I would say is, and I don't know how it works in all platforms, but inside of Codefresh, what we typically do is we allow you to specify pipeline concurrency. And what I mean by that is if you have a ton of commits coming to dev, but you actually only care about building the latest one, then you could specify that you only build the latest build and it'll actually remove the other builds in queue so that you're only building what's necessary. Now, if you're talking about like ephemeral environments or like feature testing environments, then what you might want to do at that point is you might want to take Argo's app of apps approach, where you can actually spin up like a dynamic version of just that instance of that dev feature. And then from there, you have sort of an umbrella chart that manages the deployment process. So I hope that answered that question.
Cool. Looking at this Canary deploy model with Codefresh and Argo, I noticed there wasn't more mention about how to automate that process. For Flux, they have Flagger, which it does automated roll forward from 25% to Canary to 100%, or to completely roll back if error rates on Canary hit too high of a threshold. Is there something like that for this scenario with Argo and Codefresh?
Yeah, so we actually do have that, and it's interesting. So we have a it's called a Kubernetes health check step, but what it actually allows us to do is execute a rollout process, and then you specify the time frame over which that rollout is actually taking place, and then in that health check, we can actually call out to things like looking at Kubernetes health, or let's say Spring Actuator checks for health checks, or even looking at things like Datadog and checking SLOs. And then if that SLO ever fails, then we would call the rollback procedure to actually do that. And you can do that in our pipeline processes. So the way that I've typically seen our customers implement it is that they actually have a pipeline call to another pipeline. So we support pipeline inheritance. So what they would do is they would execute the CD pipeline, which does the rollout process. And then at the end of that pipeline, they would call out to another analysis pipeline, which is going to programmatically analyze the success or failure of that based on key metrics and things that you're looking for, and then execute a rollback if necessary.
Okay, great. Any more questions? Don't be shy. Do we have to install a controller for the rollout CR into the production environment?
So you can install the, it's interesting. So you can install the CRD on its own, but the controller is what's really doing the heavy lifting. So Argo CD is made up of three major components. You have your API controller, you have the application controller, and then you have the server, I believe. And those are all necessary to really make the Argo rollout fully featured and fully functional.
Well, that looks like all the, oh, there we go. Oh, that was a thanks.
Yeah,
Thanks
of course.
for the answer.
I hope it was helpful.
For the presentation. Any more questions? Well, shoot them along. I'll start wrapping up, but if any more pop up, we can ask them. Well, thanks, Brandon, for a great presentation. We'll have the recording and slides up later today on the CNCF webinar page, and we hope to see you all again at another CNCF webinar. Thank you.
Yeah, thanks, everyone.